You and I, we've all seen pictures of Earth from space. The familiar blue marble covered with white clouds, continents visible in greens and browns, a world that looks large and detailed and unmistakably alive. Those images, taken from low orbit or from the moon, show us a world that still feels substantial, a globe we can recognize and mentally inhabit. But there is another photograph of Earth, taken from so far away that our planet doesn't look like a home anymore. It looks like a question, something that changes how we understand our place in the cosmos. On February 14th, 1990, a spacecraft called Voyager 1 turned its camera back toward the inner solar system from a distance of approximately 6 billion kilometers and captured an image that would become one of the most significant photographs ever taken. In that image, Earth appears not as a blue marble, but as a tiny point of light, a pale blue dot suspended in a scattered ray of sunlight. Easy to miss unless someone tells you where to look. At first glance, it doesn't seem special. It's grainy, faded, and almost forgettable. And then you realize what you're looking at. This tiny speck, barely distinguishable from the darkness surrounding it, is everything we have ever known. Every person who has ever lived. Every civilization that has ever risen and fallen. Every moment of joy and sorrow in all of human history. From 6 billion kilometers away, the world that seems so vast when we walk upon it nearly disappears, reduced to a mote of dust floating in an immense emptiness. The photograph captures something that words struggle to convey, a perspective on our situation that no amount of description can fully communicate. Tonight, we're going to explore that image, how it was taken, what it actually shows, and why it continues to matter more than 30 years later. This is a journey of perspective, an invitation to see our world as it appears from the edge of the solar system, and to contemplate what that view means for how we understand ourselves. You can listen closely or let the words drift past as you rest. Either way, carrying with you the quiet wonder of seeing Earth as a point of light in the cosmic dark. If this kind of slow exploration helps you unwind, consider subscribing and feel free to share in the comments where you are listening from tonight. You're watching The Drowsy Astronaut. Let us begin. The pale blue dot image is not beautiful in any conventional sense. Not a stunning portrait like the photographs astronauts have taken from the International Space Station, or the iconic Earthrise image captured during the Apollo missions. Those images show a world with texture and detail, clouds and oceans visible, the planet appearing vibrant and three-dimensional against the blackness of space. They are images you might frame and hang on a wall, immediately recognizable as photographs of something magnificent. The pale blue dot is different, almost abstract in its simplicity, a small smudge of light that requires explanation before its significance becomes apparent. The frame is dominated by bands of scattered sunlight, artifacts of the camera's optics rather than features of space itself, cutting across the image in pale stripes of orange and blue. Somewhere within one of these bands, if you look carefully and know where to look, there is a tiny point of light that appears almost indistinguishable from image noise. That point is Earth, captured from a distance so great that our entire world has been compressed into something smaller than a grain of sand on a beach, smaller than a period at the end of a sentence, smaller than almost anything you could meaningfully compare it to. The photograph shows what Earth actually looks like from the outer reaches of our solar system, a perspective that no human eye has ever directly witnessed, but that the camera of Voyager 1 was able to capture and transmit back to us. The image was not the result of a scheduled scientific observation, but rather of a special request, a final gesture before the spacecraft's cameras were shut down permanently to conserve power for the long journey ahead. Voyager 1 had completed its primary mission of exploring Jupiter and Saturn years earlier and was now heading outward toward the boundary of the solar system. Its imaging equipment no longer needed for planetary science. The photograph was taken not to discover something new about Earth, but to gain a perspective on what we already knew. The distance from which the image was captured, approximately 6 billion kilometers, represents a scale that the human mind struggles to truly comprehend. Numbers so large they become abstract rather than meaningful. 6 billion kilometers is roughly 40 times the distance from Earth to the Sun, a journey that light itself requires more than 5.5 hours to complete. The radio signal carrying this image back to Earth traveled at the speed of light, and still the transmission took hours to arrive. To put this distance in more tangible terms, if you could drive a car at highway speeds continuously without stopping, the journey would take roughly 7,000 years, longer than all of recorded human history. If you could fly in a commercial airplane at cruising speed, the trip would take over 1,000 years. Even the Voyager spacecraft itself, traveling at roughly 17 kilometers per second, required more than 12 years to reach this distance from its launch point on Earth. From 6 billion kilometers away, the Sun itself appears as just a very bright star, rather than the overwhelming presence it seems from Earth's surface. The warmth that sustains all life on our planet, the light that illuminates our days, the gravitational anchor that holds our world in its orbit, all of this becomes merely a bright point in the distance when viewed from where Voyager took this photograph. Earth, so much smaller and dimmer than the Sun, becomes correspondingly harder to see. The fact that Earth is visible at all in the pale blue dot image is somewhat remarkable, a testament to both the sensitivity of Voyager's camera and the persistence of those who insisted the photograph be taken. Many at NASA questioned whether the image would show anything meaningful, whether the effort and risk of turning the spacecraft were justified for a photograph of scientific curiosity rather than scientific value. The answer came when the image arrived on Earth and revealed that tiny point of light. The circumstances that led to the pale blue dot being captured are themselves part of the image's significance, reflecting the human impulse to look back at where we came from, even as we venture into the unknown. Voyager 1 was never designed to take this photograph, was never intended to turn its camera back toward Earth from such a distance. The spacecraft was built for planetary exploration, for close-up studies of Jupiter and Saturn, for scientific observation rather than philosophical reflection. The idea of taking a photograph of Earth from the outer solar system came from Carl Sagan, the astronomer and science communicator who had been involved with the Voyager mission from its early planning stages. Sagan understood that such an image would have no scientific value in the traditional sense. It would tell us nothing new about Earth's atmosphere or geology, nothing that our own satellites could not observe far better from close range. But he also understood that science is not the only form of knowledge worth pursuing. Sagan proposed that before Voyager's cameras were shut down, the spacecraft should turn and capture a family portrait of the solar system, a series of images showing the planets from the outside looking in. NASA initially resisted, concerned about the risk of pointing the sensitive camera toward the sun, and uncertain whether the philosophical value of such images justified the effort. But Sagan persisted, and eventually, in February of 1990, the photographs were taken. The family portrait that resulted included images of Venus, Jupiter, Saturn, Uranus, and Neptune, each appearing as a point of light at various positions in the solar system. Mercury and Mars were too close to the Sun to be captured without damaging the camera. Pluto, still considered a planet at the time, was too small and too distant to appear in the images. But Earth was there, barely visible, a pale blue dot in the darkness. The color of Earth in the image, that pale blue that gives the photograph its name, is real. Not an artifact of imaging or processing, but an actual representation of how our planet appears from that tremendous distance. The blue comes from our oceans and atmosphere, the same blue that astronauts see when they look down at Earth from orbit. Compressed now into a single point of light that nonetheless retains its characteristic hue. The paleness of that blue reflects the difficulty of seeing Earth at all from such a distance. The light from our small world spread thin across billions of kilometers of empty space, attenuated by distance until it barely registers against the darkness. A brighter blue might seem more impressive, more obviously Earth, but the paleness is honest. This is truly how our world appears when viewed from the edge of the solar system, not enhanced or exaggerated. The scattered light bands crossing the image, within one of which Earth happens to appear, are the result of sunlight reflecting inside the camera's optics, not features of space itself. In a different sense, though, they are appropriate, making Earth appear to be suspended in a sunbeam caught in a ray of light from the distant sun that still, even at this tremendous distance, provides illumination. The accident of timing and geometry that placed Earth within one of these bands has become part of the image's poetry. The image quality itself, grainy and somewhat degraded, reflects the limitations of 1970s technology, operating at the extreme edge of its design parameters. Voyager's cameras were never intended for this kind of observation, and the long exposure times required to capture enough light from such a distant target introduced noise into the image. Yet this graininess adds rather than detracts from the photograph's power, making it feel raw and authentic. The pale blue dot photograph asks us to hold two seemingly contradictory thoughts simultaneously: that Earth is precious beyond measure, and that Earth is vanishingly small in the cosmic context. These thoughts are not actually contradictory, but they require a kind of mental flexibility to embrace together. A willingness to see our world as both significant and tiny, depending on the scale we choose to employ. From the perspective of everything we know and care about, Earth is literally everything. The only world where human beings have ever lived, the repository of all our art and science and history, the home of everyone we love and everyone we have ever heard of. Nothing matters more than this planet, because this planet is where everything that matters to us exists. From this perspective, Earth is not just significant, but supreme. Yet from the perspective of the cosmos, Earth is almost nothing. A small rocky world orbiting an ordinary star in an unremarkable region of a typical galaxy. One planet among billions in our galaxy alone, that galaxy one among trillions in the observable universe. The universe does not care about Earth any more than it cares about any other point in space, does not notice our existence, does not mark our presence. From this perspective, Earth is vanishingly insignificant. The pale blue dot invites us to hold both perspectives at once, to feel the weight of our cosmic insignificance without losing sight of our local significance, to understand that meaning is something we create rather than something the universe provides. The photograph does not tell us how to feel about what it shows. It simply shows us what is true and invites us to respond. The tiny point of light in the pale blue dot photograph contains multitudes. Every person who has ever drawn breath, gathered on a stage smaller than a grain of sand in the cosmic theater. When we look at that image, we are looking at ourselves from an impossible distance, seeing the container that holds all of human experience reduced to something almost invisible. The exercise of contemplating what that dot contains is itself a form of meditation, a way of understanding our situation through radical change of perspective. Every human being who has ever lived was born on that pale blue dot, drew their first breath in its atmosphere, opened their eyes to its light, and eventually closed them for the last time somewhere on its surface. The estimated 100 billion humans who have existed since our species emerged have all shared this same small world, separated by time but united by place. Cleopatra and Einstein, anonymous farmers and celebrated artists, conquerors and peacemakers, all of them lived out their entire lives on that point of light. The cities that seem so permanent when we walk their streets, the monuments built to last forever, the borders drawn and redrawn across centuries of conflict. All of this exists on a speck that Voyager's camera could barely detect. New York and Tokyo, ancient Rome and Babylon, civilizations that rose and fell before recorded history, all compressed into something smaller than a pixel, indistinguishable from the darkness surrounding it. The scale reduction is so extreme that the mind struggles to hold on to what it means. Every war ever fought was fought on that dot. Every border dispute and territorial conflict and imperial conquest taking place on a world so small that the entire thing could be missed with a casual glance at the photograph. The rivers of blood that have been spilled throughout human history, the suffering inflicted in the name of ideology or religion or simple greed, all of it contained on a mote of dust floating in the void. The perspective does not make these events less tragic, but it does make them seem strangely local. The great achievements of human civilization, like its great failures, all occurred on that pale blue dot. Every work of art and scientific discovery emerging from the same tiny world, the music of Bach and Mozart, the paintings of the Renaissance, the literature that has moved readers for millennia, all created on a planet that appears as a faint smudge of light when viewed from 6 billion kilometers away. The beauty that humans have brought into existence has no cosmic significance, yet it matters immensely to us. The libraries that contain our accumulated knowledge, the universities where that knowledge is extended and transmitted, the laboratories where the secrets of nature are patiently uncovered, all of these exist on that dot. Every book ever written, every theorem ever proved, every experiment ever conducted took place on the same small world that Voyager photographed in 1990. Our understanding of the universe, ironically, has emerged entirely from one almost invisible point within it. The pale blue dot photograph was taken by technology developed on that same dot, conceived by minds that evolved there, built by hands that had never touched any other world. Voyager itself was assembled on Earth, launched from Earth, and sent outward to explore the solar system that Earth is part of. The spacecraft that looked back at its home did so using human ingenuity, human curiosity, and human persistence, qualities that emerged on that pale blue dot and nowhere else that we know of. The photograph represents a kind of self-portrait, humanity looking at itself from the outside, using technology to achieve a perspective that would otherwise be impossible. No human being has ever been as far from Earth as Voyager was when it took this image, and none may be for centuries to come. The photograph was taken by proxy, our robotic emissary providing a view that we could not obtain with our own eyes. Every ecosystem on Earth, every species of plant and animal, every bacterium and fungus and microscopic organism, all of it exists on that pale blue dot, and as far as we know, nowhere else in the universe. The biodiversity that has evolved over billions of years, the intricate web of relationships that connects living things, the sheer abundance of life on our planet, all compressed into a point of light barely distinguishable from the surrounding darkness. The forests that produce the oxygen we breathe, the oceans that regulate our climate, the soil that grows our food, all of this biological infrastructure exists on that tiny dot. From 6 billion kilometers away, there is no way to see the green of the Amazon or the blue of the Pacific. No way to detect the presence of life at all. The photograph shows only light, not the living systems that make our planet unique among all the worlds we have yet discovered. The evolutionary history of life on Earth, stretching back nearly 4 billion years, has unfolded entirely on that pale blue dot, generation after generation, living and dying and passing on their genes. The first cells, the first multicellular organisms, the first animals and plants and fungi, all of them arose on this one world, part of a single continuous experiment in biology that has produced everything from bacteria to whales. We are part of that experiment, one species among millions. The rarity of life in the cosmos, as far as current evidence suggests, makes that pale blue dot even more precious than its size alone would indicate. We have not yet found life on any other world, despite decades of searching, despite the discovery of thousands of planets orbiting other stars. Earth may not be the only living world in the universe, but it is the only one we know of, and that knowledge adds weight to the pale blue dot photograph. Every relationship you have ever had, every friendship and family bond and fleeting connection with a stranger has occurred on that pale blue dot. The people you love most in the world, the communities you belong to, the strangers you pass on the street, all of them share this same small home, this same point of light in the cosmic dark. The social fabric that holds human civilization together exists entirely on that dot, nowhere else. The languages we speak, the cultures we create, the traditions we pass from generation to generation, all of these exist only on Earth. Expressions of human creativity that have no equivalent anywhere else we have discovered. The diversity of human experience, the countless ways of being human that different cultures have developed. All of it happens on a world that appears as less than a pixel when photographed from the outer solar system. The future of humanity, whatever it may hold, will unfold on that pale blue dot for the foreseeable future, and possibly forever. We may someday establish outposts on other worlds, may colonize the moon or Mars, may eventually venture to the stars. But for now and for generations to come, Earth will remain home for the vast majority of human beings. Our fate is bound to that tiny point of light. The pale blue dot photograph does not diminish the importance of what happens on Earth, but rather emphasizes it by providing contrast. Against the backdrop of cosmic vastness, the activities of human life become more precious rather than less. More significant because they are so concentrated, so local, so dependent on this one small world. Everything that matters to us exists on that dot. The photograph also contains, of course, the photographer, not a human being, but a spacecraft, yet one that represents human presence and human intention in the outer solar system. Voyager 1, at the moment it captured this image, was the most distant human-made object in existence, carrying with it the hopes and curiosity of the species that built it. The spacecraft was looking back at its makers from farther away than any human creation had ever been. Attached to Voyager is the Golden Record, a phonograph record containing sounds and images from Earth, music and greetings in dozens of languages, intended as a message for any beings who might someday find the spacecraft drifting through interstellar space. The record is a kind of backup for the pale blue dot, a more detailed portrait of Earth and its inhabitants encoded in grooves of gold-plated copper. If the photograph shows where we are, the record shows who we are. The presence of the Golden Record on Voyager adds another layer to the pale blue dot photograph, a reminder that the image was taken not just for scientific or philosophical purposes, but as part of a larger effort to represent humanity to the cosmos. The spacecraft that looked back at Earth carries with it an invitation to dialogue, a hope that we are not alone, a gesture of openness to whatever intelligences might exist in the galaxy beyond our own small world. The photograph and the record together tell a story about human beings at a particular moment in our history. A species just beginning to venture beyond our home planet, curious about what lies beyond, hopeful about what we might find, and aware of how small and precious our world truly is. That story continues to unfold. Voyager 1 began its journey on September the 5th, 1977. Launched from Cape Canaveral atop a Titan IIIe Centaur rocket that lifted it out of Earth's gravity well and set it on a trajectory toward the outer planets. The spacecraft was one of a pair, with Voyager 2 having launched 16 days earlier on a different trajectory. Both missions designed to take advantage of a rare alignment of the outer planets that occurs only once every 175 years. The Voyager spacecraft were built to explore Jupiter and Saturn, with the possibility of extended missions to Uranus and Neptune if the spacecraft survived their primary objectives. They carried 11 scientific instruments each, designed to study planetary atmospheres and magnetospheres, to photograph moons and ring systems, to measure radiation and magnetic fields. The missions were ambitious but finite, expected to last perhaps 4 years before the spacecraft either failed or completed their objectives. The design of the Voyagers reflected the technology available in the 1970s, computers with less processing power than a modern calculator, cameras that used Vidicon tubes rather than digital sensors, tape recorders for data storage, and nuclear power sources that would gradually decay over decades. Everything had to work reliably for years without any possibility of repair. Had to survive the harsh radiation environment around Jupiter, had to function in the cold darkness of the outer solar system, far from the sun's warmth. The spacecraft were remarkably successful, exceeding all expectations for durability and scientific return. Voyager 1 flew past Jupiter in March of 1979, sending back images of the Great Red Spot, the volcanic moon Io, and the complex dynamics of Jupiter's atmosphere. The encounter provided a gravitational assist that bent the spacecraft's trajectory towards Saturn, which it reached in November of 1980. The Saturn encounter was equally spectacular, with Voyager 1 passing through the ring plane and examining the intricate structure of the rings in unprecedented detail. The spacecraft flew close to Titan, Saturn's largest moon, revealing a world with a thick atmosphere and complex organic chemistry, though the moon's surface remained hidden beneath an orange haze. The close approach to Titan bent Voyager 1's trajectory out of the plane of the solar system, ending any possibility of visiting Uranus or Neptune, but sending the spacecraft on a faster path toward interstellar space. After the Saturn encounter, Voyager 1's primary mission was complete, but the spacecraft continued functioning far better than anyone had expected. It was now heading out of the solar system, climbing away from the sun at an angle that would eventually carry it into the space between the stars. The scientific instruments continued operating, measuring the solar wind and cosmic rays, tracking the boundary of the sun's influence as it gradually approached. The years after Saturn were quieter for Voyager 1. The spacecraft no longer encountering planets or moons, simply traveling outward through increasingly empty space. The cameras were not needed for this phase of the mission, and to conserve power for the instruments that were still collecting data, they were eventually scheduled to be turned off permanently. The spacecraft that had sent back thousands of stunning images would become blind, continuing its journey without seeing where it was going. It was during this transition period, as the camera system prepared for its final shutdown, that Carl Sagan's proposal for the family portrait was implemented. The opportunity to capture one final set of images, looking back at the solar system from a distance that would never be matched by these cameras, was too significant to pass up. In February of 1990, Voyager 1 turned and looked homeward one last time. The process of taking the pale blue dot photograph was not simple, requiring careful planning to avoid damaging the sensitive camera by pointing it too close to the sun. The sun, from Voyager's distance, was still by far the brightest object in the sky, capable of overwhelming the camera's sensors if they were exposed directly. The imaging team had to calculate safe angles and exposure times, balancing the desire to capture the inner planets against the risk of harming the equipment. The family portrait sequence took several hours to complete, with Voyager rotating to capture images in different directions, building up a mosaic that would show the positions of the planets scattered across the solar system. 60 frames were taken in total, creating a panorama that stretched across the sky as seen from 6 billion kilometers away. Most of those frames showed nothing but scattered sunlight and darkness, the planets appearing as tiny points in only a few of the images. The data from these images took hours to transmit back to Earth, traveling at the speed of light across the immense distance between Voyager and the receiving antennas of the Deep Space Network. The signal was faint, the power available for transmission limited, and the bandwidth correspondingly narrow. Each image arrived as a stream of numbers that had to be reconstructed into pictures, a process that required patience and careful processing. When the images finally arrived and were processed, the pale blue dot emerged. That tiny speck within the scattered light, barely visible, easily overlooked, yet undeniably present. Earth was there, captured by a spacecraft that had been its emissary to the outer planets, and was now departing the solar system entirely. The photograph was a farewell glance, a last look back, before the cameras closed forever. After the family portrait was complete, Voyager 1's imaging system was indeed shut down. The cameras powered off to conserve electricity for the instruments still monitoring the space environment around the spacecraft. The Voyager would continue its scientific mission, studying the heliosphere and eventually the interstellar medium. But it would do so blind, no longer able to see where it was going or what it was passing. The spacecraft continues operating to this day, more than 47 years after its launch, still transmitting data back to Earth from distances that now exceed 24 billion kilometers. Its power supply has degraded, forcing the shutdown of more and more instruments over the years. But some scientific measurements continue. Voyager 1 remains the most distant human-made object in existence, a record it will likely hold for decades to come. The journey that led to the pale blue dot photograph was never intended to produce that image, the spacecraft designed for planetary exploration rather than philosophical reflection. Yet the photograph has become one of Voyager's most significant legacies, an image that transcends its scientific context to become a cultural touchstone. The spacecraft that looked back at Earth provided a perspective that no other human creation has ever matched. The cameras that took the pale blue dot have been silent for more than 3 decades now. Their work complete, their view of the cosmos ended. But the image they captured continues to circulate, continues to inspire, continues to provide the cosmic perspective that Carl Sagan hoped it would when he first proposed turning the spacecraft around. The photograph outlives the camera that took it. The technology that enabled the pale blue dot photograph seems primitive by current standards. Computing power that a smartphone would exceed many times over. Imaging sensors that pale in comparison to modern digital cameras. Yet this 1970s technology was sufficient to capture something profound, demonstrating that significance does not require sophistication. The image works because of what it shows, not because of how it was made. The limitations of Voyager's cameras actually contributed to the photograph's character. The graininess and scattered light, giving the image a raw, authentic quality that a cleaner picture might lack. The pale blue dot appears fragile, in part because the image itself is fragile. A faint signal extracted from noise, a tiny point of light almost lost in the technical artifacts of the imaging process. The difficulty of capturing Earth from that distance becomes part of the story. Voyager 1 continues outward, now in interstellar space, the first human-made object to leave the heliosphere and enter the medium between the stars. The spacecraft is moving away from Earth at roughly 17 kilometers per second, a speed that sounds impressive, but that will nonetheless require tens of thousands of years to reach even the nearest stars. The journey that began in 1977 continues. slow by cosmic standards but relentless. The pale blue dot remains behind, frozen in time at the moment of its capture. Earth as it appeared on February 14th, 1990. The planet has continued its orbit around the sun. Seasons have changed. Generations have lived and died. But the photograph preserves that one moment when Voyager looked back and saw our world as a point of light in the darkness. The idea of taking a photograph of Earth from the outer solar system did not emerge from NASA's mission planning or from the scientific objectives of the Voyager program, but rather from the mind of a scientist who understood that some knowledge is philosophical rather than empirical. Carl Sagan had been involved with the Voyager mission since its inception, serving on the imaging team and contributing to the scientific goals. But his vision extended beyond what the instruments were designed to measure. Sagan first proposed the family portrait concept in the early 1980s, suggesting that before Voyager's cameras were shut down, the spacecraft should turn and capture images of the planets from its unique vantage point. The scientific value of such images would be minimal. They would show nothing about the planets that closer observation could not reveal better. But the philosophical value, Sagan argued, would be immense. The images would provide a perspective on our solar system that had never before been possible. The proposal met with resistance at NASA, where resources were limited and priorities were carefully managed. Taking the family portrait would require turning the spacecraft, consuming attitude control propellant that was in finite supply, and risking damage to the camera by pointing it toward the sun. The scientific return would be negligible. The data consumed by the imaging would reduce the bandwidth available for other instruments, and the whole exercise seemed more sentimental than substantive. Sagan persisted, making his case repeatedly over the course of several years, arguing that the Voyager missions were not just scientific endeavors, but cultural ones, that the spacecraft represented humanity's first steps into the outer solar system and should acknowledge that significance. He emphasized that the opportunity was unique and would not come again. Once the cameras were shut down, no other spacecraft would be positioned to take similar images for decades, perhaps longer. The debate over the family portrait reflected deeper questions about the purpose of space exploration and the role of public engagement in scientific missions. NASA had traditionally focused on scientific objectives that could be measured and quantified, results that could be published in peer-reviewed journals and that justified the expenditure of public funds. Philosophical reflection, however valuable, did not fit neatly into this framework. Yet Sagan understood that public support for space exploration depended on more than scientific papers, that people needed to feel connected to the missions their tax dollars funded. The Voyager spacecraft had captured public imagination with their stunning images of Jupiter and Saturn, pictures that appeared on magazine covers and television screens around the world. Those images did have scientific value, but their cultural impact came from their beauty and their ability to evoke wonder. The pale blue dot photograph, Sagan argued, would serve a similar purpose, not by showing something new, but by providing a perspective that could change how people thought about their place in the universe. The image would be a gift to the public that had funded the mission, a way of returning something valuable beyond data and discoveries. Science could serve more than itself. The resistance to Sagan's proposal was not hostile, but practical. reflecting the genuine constraints that mission managers faced. Every decision about Voyager involved trade-offs, and the family portrait would consume resources that could not be recovered. The concern about camera damage was real, pointing sensitive optics toward the sun, even from 6 billion kilometers away, carried genuine risk. The decision required weighing intangible benefits against tangible costs. Eventually, after years of advocacy, Sagan's proposal was approved, and the family portrait was scheduled for February of 1990, just before the camera system was to be shut down permanently. The timing was significant. The cameras would take their final images and then fall silent, making the family portrait literally the last photographs Voyager 1 would ever capture. The spacecraft would look back at home one final time before going blind. The decision to approve the family portrait reflected a recognition that space exploration served purposes beyond the purely scientific, that the missions humanity sent into the cosmos carried meaning that transcended their instrumental objectives. The Voyager spacecraft were not just data-gathering platforms, but emissaries, representatives of a species taking its first tentative steps beyond its home world. Acknowledging that significance was appropriate, Sagan's persistence in advocating for the photograph demonstrated his conviction that scientists had responsibilities extending beyond their narrow disciplines, that those who understood the cosmos had an obligation to share that understanding with others. He was not content simply to study the universe. He wanted to help others appreciate what science revealed. The family portrait was an expression of this conviction. The approval of the photograph also reflected the unique circumstances of the moment. A spacecraft that had completed its primary mission, cameras that were about to be shut down regardless, a window of opportunity that would close and never reopen. The marginal cost of taking the images was low compared to the potential cultural value, a calculation that tipped the balance in favor of Sagan's proposal. The planning for the family portrait sequence required careful coordination between the imaging team and the navigation team, calculating exactly how to orient the spacecraft to capture each planet while avoiding the sun. The sequence would take several hours to execute, with Voyager rotating to different positions and taking images in multiple directions to build up the complete mosaic. Safety margins were built into the plan to protect the camera from solar damage, ensuring that no image would be taken with the sun closer than a specified angle to the camera's field of view. These margins meant that some planets could not be captured. Mercury and Mars were too close to the sun's apparent position to photograph safely. But Earth, Venus, Jupiter, Saturn, Uranus, and Neptune were all within range. The commands for the imaging sequence were transmitted to Voyager well in advance, traveling at the speed of light, but still requiring hours to reach the spacecraft at its immense distance. Once received, the commands were stored in Voyager's memory and executed automatically at the programmed times, the spacecraft too far away for real-time control from Earth. On February 14, 1990, Voyager 1 executed the sequence as planned, rotating through the prescribed positions and capturing 60 images that together formed the family portrait. The data were recorded on the spacecraft's tape system and then transmitted back to Earth over the following days, the narrow bandwidth requiring extended transmission times for each image. When the data arrived and the images were processed, the result exceeded what many had expected. not in scientific content, but in emotional impact. The planets appeared as tiny points of light, barely distinguishable from stars, yet undeniably present, our solar system seen from outside for the first time in human history. And there, in one of those images, was Earth, the pale blue dot. Carl Sagan's reaction to the image reflected his understanding of what it meant. His recognition that the photograph captured something that could not be measured or quantified, but that nonetheless mattered. He would spend the remaining years of his life reflecting on the image and its implications, eventually publishing his thoughts in the book that shares its name with the photograph. The request that Sagan had made, and that NASA had eventually approved, proved justified by the response the image received, the way it resonated with people who saw in it something true about their situation in the cosmos. The photograph became one of the most famous images ever taken, reproduced and referenced countless times. Used in contexts ranging from environmental advocacy to philosophy of mind, the story of how the pale blue dot came to be taken is itself part of its meaning, demonstrating that cultural significance sometimes requires advocacy, that valuable perspectives do not always emerge automatically from scientific processes. Someone had to imagine the photograph before it could be taken, had to argue for its value, had to persist against resistance. The image exists because Carl Sagan believed it should. The pale blue dot was not a single photograph, but part of a larger project, a family portrait of the solar system that captured 6 planets in a series of images taken over several hours on that February day in 1990. The portrait represented the first and, so far only, time that the solar system has been photographed from outside. A view that transformed our familiar neighborhood into something strange and small. The imaging sequence began with Voyager, oriented to capture the outer planets, those farthest from the Sun and therefore safest to photograph without risk of camera damage. Neptune appeared first, the most distant planet the Voyagers had visited, a tiny point of blue-green light, barely distinguishable from the background. The photograph showed none of the detail that Voyager 2 had captured during its close flyby just months earlier, reducing the planet to a mere dot. Uranus followed, equally reduced to a point of light, the planet that Voyager 2 had visited in 1986, transformed back into the faint object that had eluded detection for most of human history. From Voyager 1's distance, the planet that had revealed its tilted axis and strange magnetic field was simply another speck, indistinguishable from countless stars, except for its position. Saturn appeared as a slightly larger point, the magnificent ring system that had captivated observers for centuries. Now invisible, the planet reduced to a single spot of light. The spacecraft that had sent back stunning images of Saturn's rings and moons in 1980 now saw only a distant point where all that complexity was hidden. The reduction was dramatic. Jupiter, the largest planet in the solar system, appeared as the brightest point in the family portrait sequence. Its immense size still detectable, a slightly greater apparent brightness compared to the other planets. The great red spot that had fascinated astronomers for centuries, the swirling clouds and violent storms, the intricate patterns of bands and zones. None of this was visible, all compressed into a single point of light. The inner solar system was more challenging to photograph. The planets closer to the Sun, and therefore requiring more careful positioning of the spacecraft to avoid damage. Venus was captured successfully, appearing as a bright point of light, the hottest planet in the solar system, reduced to a dot like all the others. Mercury and Mars could not be safely photographed, their apparent positions too close to the Sun for the camera to capture without risk. These two planets are absent from the family portrait, their positions in the sequence left empty by the constraints of spacecraft safety. The portrait is incomplete, yet powerful nonetheless. And then there was Earth, the third planet from the Sun, our home world, appearing in one of the frames as a tiny point of pale blue light, suspended in a scattered ray of sunlight. The image showed Earth and the Moon together. Though the Moon was not separately visible, both worlds compressed into that single, barely distinguishable point. Everything we know, captured in less than a pixel. The mosaic that resulted from the family portrait sequence showed the solar system as it had never been seen before. The planets scattered across a vast darkness, each reduced to a point of light that conveyed nothing of its individual character. The image was simultaneously humbling and informative, showing the true arrangement of our cosmic neighborhood, as seen from outside. The spacing between the planets in the mosaic reflected their actual positions in February of 1990. A snapshot of a constantly changing configuration as each planet pursues its own orbit around the Sun. The same sequence taken months earlier or later would have shown different relative positions. The planets arranged differently across the frame. The family portrait captured one moment in the endless dance. The darkness between the planets dominated the mosaic, emphasizing how much empty space exists in the solar system, how isolated each planet truly is from its neighbors. The dots of light were scattered through an immense void, separated by millions or billions of kilometers of nothingness. The solar system that seems full of objects is actually mostly empty. From Voyager's perspective, looking back at the solar system from the outside, the Sun itself appeared as just another bright point, far brighter than the planets, but still just a star rather than the overwhelming presence it seems from Earth. The source of all warmth and light for our world was reduced to a point, the nuclear furnace at the center of our system appearing almost modest from 6 billion kilometers away. The family portrait accomplished what Carl Sagan had hoped it would, providing a perspective on our solar system that could not be obtained any other way, showing us our cosmic neighborhood as an outside observer would see it. The image was not scientifically valuable in the traditional sense. It revealed no new information about the planets, but it was profoundly valuable as a way of seeing. The portrait also demonstrated the isolation of our solar system within the larger galaxy, the vast distances that separate us from other stars and other potential solar systems. From 6 billion kilometers away, the solar system was already barely visible. From the distance of even the nearest star, it would be completely invisible to cameras like Voyager's. We are alone in an immense emptiness. The family portrait has been reproduced and referenced many times in the decades since it was taken, appearing in documentaries and textbooks and discussions of our place in the cosmos. The mosaic provides context for the pale blue dot specifically, showing that Earth is just one of several planets reduced to points of light, not unique in its apparent insignificance when seen from far enough away. Yet Earth is unique in another sense, the only one of those points of light known to harbor life. The only one where beings have evolved who can look back at themselves from the outer solar system and contemplate what the image means. The pale blue dot is special, not because of how it appears in the photograph, but because of what it contains. The family portrait was Voyager 1's farewell to the solar system, the last images the spacecraft would ever take before its cameras were shut down and it continued its journey outward in blindness. The photograph was a backward glance, a moment of reflection before plunging into the unknown darkness between the stars. After the family portrait was complete and the images transmitted back to Earth, the camera system was indeed powered down, the spacecraft no longer needing to see where it was going. Voyager 1 would continue traveling outward for years, for decades, eventually for thousands and millions of years, but it would do so without sight, navigating by mathematics rather than observation. The decision to take the family portrait as the camera's final act gave the images additional poignancy, a sense of closure and farewell that amplified their emotional impact. The last thing Voyager saw was its home, the place from which it had come and to which it would never return. The gesture was sentimental in the best sense, an acknowledgement that machines can carry human meaning even when they are not human themselves. The portrait remains, preserved in NASA's archives and reproduced across countless media, a permanent record of how our solar system appeared on the February day when a spacecraft at its edge looked back and captured what it saw. The moment is frozen, the configuration preserved, the family of planets gathered in their scattered arrangement for anyone who wishes to see. The distance from which the pale blue dot photograph was taken, approximately 6 billion kilometers, is a number that can be stated easily, but that resists true comprehension. A gulf of space so vast that familiar measures become meaningless. Understanding this distance, or at least appreciating its scale, is essential for grasping what the photograph represents and why Earth appears so small within it. 6 billion kilometers is roughly 40 astronomical units, where 1 astronomical unit is the average distance between Earth and the Sun, about 150 million kilometers. The Earth-Sun distance, already difficult to conceptualize, must be multiplied by 40 to reach Voyager's position when the photograph was taken. Each doubling of distance reduces apparent size by half, and 40 times the Earth-Sun distance means Earth appears as a very tiny point indeed. Light, the fastest thing in the universe, requires approximately 5.5 hours to travel 6 billion kilometers. When Voyager took the pale blue dot photograph, the image showed Earth as it had appeared 5.5 hours earlier, the light having traveled outward to the spacecraft during that interval. The photograph was already historical the moment it was captured, showing a past that was hours old. The radio signals that carried the photograph back to Earth traveled at the same speed, the speed of light, meaning the transmission took another 5.5 hours to reach the receiving antennas of the Deep Space Network. The round-trip time for any communication with Voyager at that distance was approximately 11 hours, making real-time control of the spacecraft impossible and requiring all operations to be planned and executed autonomously. To appreciate 6 billion kilometers in more human terms, we might consider how long it would take to travel that distance using familiar modes of transportation. A commercial airplane cruising at roughly 900 kilometers per hour would require approximately 760,000 years to complete the journey, far longer than modern humans have existed as a species. A car traveling at highway speeds of around 100 kilometers per hour would need roughly 6.8 million years, a duration that spans back to before the emergence of the human genus and into the age of our earliest hominid ancestors. The journey would outlast not just individuals, but entire evolutionary lineages, species rising and falling before the destination was reached. Even light, crossing that distance in 5.5 hours, demonstrates the immensity of the gulf. Light is unimaginably fast by human standards, circling the Earth more than 7 times in a single second. Yet, it still requires hours to travel from Earth to where Voyager took the photograph. The speed of light, often treated as practically instantaneous in everyday contexts, reveals itself as a measurable and limiting factor at interplanetary scales. Voyager 1 itself, traveling at roughly 17 kilometers per second after its gravitational boosts from Jupiter and Saturn, required more than 12 years to reach the distance from which the pale blue dot was captured. The spacecraft was launched in September 1977 and took the photograph in February 1990, 12.5 years of constant travel at speeds that would cross the continental United States in a few minutes. From 6 billion kilometers away, the sun appears as a bright star rather than the dominating presence it seems from Earth's surface. The warmth that sustains all life on our planet, the light that illuminates our days, the gravitational anchor around which our world orbits, all of this is reduced to a point of light, brighter than other stars, but still just a point. The perspective fundamentally changes how the solar system appears. The intensity of sunlight at Voyager's distance was roughly 1/1600th of what it is at Earth's orbit, the inverse square law reducing illumination with the square of the distance. The solar panels that power most spacecraft would be nearly useless at this distance, which is why Voyager uses radioisotope thermoelectric generators, nuclear power sources that produce electricity from the decay of plutonium regardless of distance from the Sun. Earth, reflecting only a tiny fraction of the sunlight that reaches it, and then scattering that reflected light across billions of kilometers of space, appears incredibly faint from Voyager's position. The planet that seems so bright when we look at the Moon from Earth, that seems so vivid in photographs taken from lunar orbit, becomes barely detectable when the distance increases by a factor of thousands. The challenge of photographing Earth from 6 billion kilometers was significant, requiring long exposure times to gather enough photons for the camera to register the planet's presence. Voyager's cameras were not designed for this kind of observation, and the image quality reflects the difficulty of the task. The graininess and noise in the pale blue dot photograph are artifacts of pushing the technology beyond its intended parameters. The position of Voyager when the photograph was taken placed it well beyond the orbit of Pluto, in the outer reaches of the solar system, where few objects exist and sunlight is dim. This region, sometimes called the Kuiper Belt, contains ice dwarfs and frozen debris left over from the solar system's formation. But mostly it contains emptiness, the void between the Sun's family of planets and the true interstellar space beyond. From this vantage point, looking back toward the Sun, the entire solar system could be seen in a single panoramic view, all the planets arranged in their orbits around the distant central star. The family portrait that included the pale blue dot captured this unprecedented perspective, showing our cosmic neighborhood from an outsider's viewpoint for the first time in human history. The distance was great enough that the solar system appeared small, the orbits of the planets compressed into a relatively compact region of space compared to the vastness beyond. From 6 billion kilometers, it became clear how isolated our solar system is, how much empty space surrounds us, how far the nearest stars truly are. Yet even at this immense distance, Voyager had not yet reached the edge of the sun's influence, the boundary where the solar wind gives way to the interstellar medium. That boundary, the heliopause, lay billions of kilometers farther out, a goal that Voyager would eventually reach in 2012. More than 2 decades after the pale blue dot photograph was taken. The 6 billion kilometers that separated Voyager from Earth when the photograph was taken represent just the beginning of the spacecraft's journey. A fraction of the distance it has since traveled, and a tiny fraction of the distances that separate stars in our galaxy. From the perspective of interstellar travel, Voyager remains in our sun's immediate neighborhood, despite having traveled farther from Earth than any other human-made object. The nearest star system, Alpha Centauri, lies roughly 4 light-years away, a distance of approximately 40 trillion kilometers. Voyager 1, even after traveling for more than 4 decades, has covered less than 1% of this distance, and at its current speed would require roughly 70,000 years to reach the nearest star, if it were heading in that direction, which it is not. The vastness of interstellar space makes 6 billion kilometers seem almost local, a journey within our own solar system rather than a venture into the galaxy beyond. The pale blue dot photograph was taken from a distance that feels immense by human standards, but that is modest by cosmic ones. The universe extends far beyond what Voyager will ever explore. Yet the photograph captured something significant, precisely because it was taken from far enough away to provide a new perspective while still close enough to be achievable with our technology. 6 billion kilometers was the right distance, far enough to reduce Earth to a point of light, close enough for our cameras to capture that point.
The pale blue dot exists at the boundary of what we could accomplish.
The technical characteristics of the pale blue dot photograph reflect the circumstances of its capture, the limitations of 1970s technology, operating at the extreme edge of its design parameters. Understanding these details helps explain why the image looks the way it does, why Earth appears so small, and why the photograph has the particular aesthetic quality that has contributed to its cultural impact. Voyager's imaging system consisted of 2 cameras, a wide-angle camera and a narrow-angle camera, both using Vidicon tube technology rather than the digital sensors that would later become standard. The narrow-angle camera, which captured the pale blue dot, had a focal length of 1500 millimeters, providing magnification that allowed detailed photographs of planetary features during close encounters, but that reduced the field of view to a small area of sky. The exposure time for the pale blue dot photograph was 0.72 seconds, a relatively long exposure that allowed enough photons from the distant Earth to accumulate on the camera's sensor. Longer exposures would have gathered more light but risked greater blurring from spacecraft motion. Shorter exposures would have produced an even fainter, noisier image. The exposure time represented a balance between competing constraints. The image was captured using a blue filter, one of several color filters available on Voyager's cameras, which contributed to the pale blue appearance of Earth in the final image. Other filters were used for other frames in the family portrait sequence, building up color information that could be combined to produce natural color images. The blue filter emphasized the blue light scattered by Earth's atmosphere and oceans. The scattered light bands that cross the pale blue dot image, creating the sunbeam-like appearance that gives the photograph much of its aesthetic power, are artifacts of light scattering within the camera optics, rather than features of space itself. The sun, though not directly in the frame, was close enough to the camera's field of view that its light scattered off optical surfaces and created these bands. The bands appear as stripes of color, pale orange, pale blue, cutting across the blackness of space, giving the image a dynamic quality that a cleaner photograph might lack. Earth happens to appear within one of the blue bands, suspended in what looks like a ray of scattered sunlight, an accident of timing and geometry that has become part of the image's poetry. The positioning of Earth within the scattered light band was not planned or predicted, simply a consequence of where the planet happened to be when the image was taken. The light scattering pattern depended on the camera's orientation relative to the sun, and Earth's appearance within a band was fortuitous. Had the timing been slightly different, Earth might have appeared in the dark region between bands. The graininess of the image results from noise in the camera's sensor, and in the transmission and processing of the data, artifacts that were more pronounced in the low-light conditions of the photograph. Modern noise reduction techniques could perhaps clean up some of this graininess, but doing so would alter the authentic character of the image. The graininess is part of what makes the photograph feel real. The camera that captured the pale blue dot had traveled more than 6 billion kilometers from the clean room where it was assembled, enduring the vibrations of launch, the radiation environment around Jupiter, and the cold darkness of the outer solar system. That it still functioned at all after 12.5 years was testament to the quality of its construction and the skill of the engineers who designed and built it. The narrow-angle camera's resolution, impressive for 1970s technology, was approximately 300 lines of picture height, far less than even a low-resolution digital camera today. The limited resolution, combined with the extreme distance and the small apparent size of Earth, meant that the planet could not be resolved as a disk. It appeared only as a point of light, smaller than the resolution limit of the camera. The data compression and transmission systems that sent the image back to Earth were equally constrained by the technology of their time. The data rate available for transmission from Voyager at that distance was measured in bits per second, requiring hours or days to transmit even relatively small amounts of image data. The pale blue dot photograph traveled to Earth as a stream of numbers, reconstructed into an image only after arrival. The entire imaging system was designed for planetary encounters, for capturing detailed photographs of cloud bands and moon surfaces from distances measured in thousands of kilometers. Using this system to photograph Earth from billions of kilometers away pushed it far beyond its intended purpose. Yet the attempt succeeded, producing an image that has outlasted any of the close-up planetary photographs in cultural significance. The colors in the pale blue dot photograph are approximately accurate, though they depend on processing choices that can shift hues slightly in different published versions. The blue of Earth, the orange-tinged scattered light, the blackness of space, these colors represent what the camera captured, translated through filters and processing into an image human eyes can appreciate. The size of Earth in the image, less than a single pixel, explains why the planet appears as a point of light rather than a disk. The camera's resolution was insufficient to capture any structure or detail at Earth's apparent size, making our planet indistinguishable from a star in terms of shape. Only the color and position identified it as Earth rather than a background star. The blackness surrounding Earth in the image is genuine. The darkness of space, as seen from the outer solar system, punctuated only by the scattered light artifacts and the tiny point that is our planet. The darkness dominates the frame, emphasizing Earth's isolation in the void, its smallness against the immensity of space. The image has been reproduced in many forms over the decades, sometimes with enhanced colors or adjusted contrast, sometimes with Earth highlighted by arrows or circles to help viewers locate it. The original image, with its graininess and artifacts intact, remains the most powerful version. Authentic in its technical limitations, honest about the difficulty of seeing our world from so far away. The technical details of the pale blue dot photograph matter because they ground the image in reality, demonstrating that it is not an artist's conception or a computer-generated simulation, but an actual photograph of an actual planet taken by an actual spacecraft from an actual distance. The artifacts and limitations are evidence of authenticity. The 1970s technology that made the image possible seems primitive now, surpassed by smartphone cameras and amateur telescopes, yet it achieved something that more sophisticated equipment has not repeated. No other spacecraft has taken a photograph of Earth from comparable distance, making the pale blue dot still unique after more than 3 decades. The photograph works not, despite its limitations, but in some ways because of them, the graininess and artifacts contributing to a sense of difficulty, of achievement against constraints, of glimpsing something at the very edge of our capabilities. The image feels earned, the product of effort and ingenuity and persistence. Understanding how the photograph was made deepens appreciation for what it shows, adding layers of meaning to an image that already carries profound significance. The technical and the philosophical intertwine, the limitations of camera optics merging with the limitless implications of seeing our world as a point of light in the cosmic dark. Carl Sagan's response to the pale blue dot photograph has become inseparable from the image itself. His words giving voice to what many feel when they contemplate Earth from this perspective. His reflection, delivered in various forms during the early 90s and eventually published in his book of the same name, remains one of the most moving pieces of science communication ever created. Sagan began by describing what the image showed, that pale blue dot suspended in a ray of scattered sunlight, barely distinguishable from the darkness surrounding it. He then invited his listeners and readers to consider what that tiny point of light actually contained, to recognize that everyone they had ever heard of, every human being who ever was, lived out their lives on that mote of dust. The word mote is deliberate, suggesting something almost invisible, easily overlooked, insignificant in size, yet carrying all the significance that matters to us. Sagan was drawing attention to the contrast between the apparent smallness of Earth in the photograph and the immensity of what it contains, the disconnect between cosmic scale and human meaning. He spoke of the rivers of blood spilled by generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. The perspective of the photograph made all human conflict seem parochial. The territorial disputes and ideological struggles taking place on a world so small that the entire thing almost disappeared when viewed from sufficient distance. The moral implications of this perspective were central to Sagan's reflection. His conviction that seeing ourselves from this vantage point should change how we treat each other and our planet. If this is all we have, if there is nowhere else to go, then we bear responsibility for preserving and cherishing this pale blue dot that is our only home. Sagan spoke of the foolishness of human pretensions and posturings in light of the photograph, the way our small-minded rivalries appear when seen from a cosmic perspective. He was not dismissing human concerns as unimportant, but rather suggesting that we might prioritize differently if we kept this perspective in mind. The photograph, in Sagan's interpretation, was a call for humility, for recognition that we are not the center of anything, that our planet is a tiny island in an immense cosmic ocean. This humility was not meant to diminish us, but to right-size us, to position us accurately in relation to the universe we inhabit. Yet Sagan also found significance in the pale blue dot. Not cosmic significance, but human significance, the meaning we create for ourselves on this small world. The photograph did not prove that we matter to the universe. It showed rather clearly that the universe is indifferent to us, but it could inspire us to matter to each other. The famous passage from Sagan's reflection has been quoted countless times. The words becoming part of cultural consciousness, even for people who have never read the full text or seen the television program in which he delivered them. The phrases have taken on a life of their own, referenced and adapted in countless contexts. Sagan said, "That's here, that's home, that's us." The simplicity of the language contrasted with the profundity of the observation, making the point accessible to anyone while losing none of its power. Sagan had a gift for finding the right words. He spoke of everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, living out their lives on that mote of dust suspended in a sunbeam. The cumulative effect of the phrases, building on each other, drove home the completeness of what the photograph contained. The totality of human experience compressed into a point of light. The reflection moved from description to implication, from observation to moral conclusion. Sagan argued that the photograph underscored our responsibility to deal more kindly with one another, to preserve and cherish the pale blue dot, the only home we have ever known. The cosmic perspective led to an earthly conclusion. Sagan's words were not neutral scientific commentary, but a passionate plea for a particular response to the photograph, a response characterized by humility, compassion, and responsibility. He saw in the image not just a scientific achievement, but a moral opportunity, a chance to think differently about ourselves. The reflection was consistent with Sagan's broader philosophy, his conviction that science could and should inform how we live, that understanding our place in the universe had implications for how we treated each other and our planet. He was not interested in knowledge for its own sake, but in knowledge as a guide to action. Critics might argue that Sagan was reading too much into a photograph, projecting philosophical conclusions onto an image that simply showed what it showed. But Sagan would likely have responded that all images require interpretation, and that the choice of how to interpret the pale blue dot was itself a moral choice. The power of Sagan's reflection came in part from his credibility as a scientist, someone who understood the cosmos, not just emotionally, but technically. He was not a poet or philosopher speaking from outside science, but a researcher speaking from within it, lending his words the authority of someone who understood the numbers and equations behind the image. The publication of Sagan's reflection in his 1994 book, Pale Blue Dot, gave his words permanent form, allowing them to be read and reread by audiences who had missed the original television presentations. The book expanded on the themes of the reflection, exploring human exploration of the solar system, and the arguments for and against expanding into space. The book's title ensured that the pale blue dot photograph and Sagan's reflection would be forever linked, the image calling forth the words and the words illuminating the image. The two have become inseparable, a paired cultural artifact where image and interpretation reinforce each other. People who encounter the photograph often encounter Sagan's words alongside it, and people who read the words often seek out the image that inspired them. The pairing has proven remarkably durable across decades. Sagan's reflection has been translated into dozens of languages, carrying its message of cosmic perspective and earthly responsibility to audiences around the world who may never have heard of Voyager or understood the technical achievement the photograph represented. The words transcend their original context, speaking to something universal about human experience. The reflection has been set to music, illustrated, animated, and adapted in countless ways by artists and creators who found something in Sagan's words that demanded expression in other media. The original text has inspired derivative works that reach audiences who might never encounter the original, spreading the perspective it articulates through cultural channels Sagan could not have anticipated. Teachers use Sagan's reflection in classrooms, introducing students to both the photograph and the philosophy it inspired, using the pale blue dot as a teaching tool for discussions about perspective, responsibility, and humanity's place in the cosmos. The material works well for such purposes because it is accessible without being simplistic, profound without being obscure. Environmental advocates have adopted the reflection as a touchstone for discussions about climate change and ecological destruction, finding in Sagan's words an articulation of why Earth matters and why its preservation should be a priority. The pale blue dot represents all we have, and damaging it is damaging ourselves. The anniversary of the photograph's capture, February 14th, has become an occasion for reflection and celebration in some communities. A day to remember the perspective that Voyager provided and to consider how that perspective might inform how we live. Valentine's Day took on an additional meaning for those who know the pale blue dot story. Sagan did not live to see how thoroughly his reflection would penetrate cultural consciousness. Dying in 1996, just 2 years after the publication of his book. He knew the photograph was important and hoped his words would help people understand why. But the full extent of their influence emerged only after his death. The reflection continues to resonate because it addresses questions that do not become dated. Questions about who we are and how we should live, and what our world means in the context of the larger universe. These are perennial concerns, and Sagan's perspective on them remains relevant regardless of technological or social changes. New generations discover the pale blue dot photograph and Sagan's reflection through the internet, encountering them for the first time and responding with the same wonder and contemplation that original audiences felt. The material has proven its ability to move people across generational and cultural boundaries. The simplicity of the photograph, just a point of light in darkness, and the accessibility of Sagan's language combine to create something that can reach almost anyone. No specialized knowledge is required to understand what the image shows or what Sagan says about it. The profundity is available to all. Some critics have suggested that Sagan's reflection is too sentimental, too quick to draw moral conclusions from a scientific image, too eager to find meaning where perhaps there is only information. But these criticisms have not diminished the reflection's influence. Perhaps because what Sagan offered met a need that purely neutral description could not satisfy. The pale blue dot photograph is, after all, just data, light captured by sensors and transmitted across the solar system. It becomes meaningful only when human minds interpret it. And Sagan's interpretation gave people a way to respond to the image that felt appropriate to its significance. He provided the words that many could not find themselves. The written version of Sagan's reflection differs slightly from the various spoken versions he delivered, refined through multiple presentations into a form that captured exactly what he wanted to say. The book version represents his final, considered statement on what the pale blue dot meant to him. Audio recordings of Sagan delivering the reflection preserve his distinctive voice, the cadence and emphasis that gave his words additional power beyond what appears on the page. His voice has become part of the reflection's meaning, inseparable from the content for those who have heard it. The reflection stands as a model for how scientific images can be interpreted, how the emotional and philosophical implications of discoveries can be articulated without abandoning scientific accuracy. Sagan did not distort what the photograph showed. He simply helped people understand what it meant. The words continue to circulate, quoted in speeches and articles and social media posts, adapted for new contexts while retaining their essential message. The pale blue dot reflection has become part of the common vocabulary for discussing Earth and humanity and our place in the cosmos. Perhaps the greatest tribute to Sagan's reflection is that it has changed how people see the photograph, making it difficult to look at that pale blue dot without thinking about what it contains, without feeling something of the humility and responsibility that Sagan articulated. The words have shaped perception. The reflection will likely continue to resonate for as long as humans contemplate their place in the universe. For as long as that small point of light in Voyager's photograph represents everything we have ever known. Sagan's words gave lasting voice to a moment of cosmic perspective that might otherwise have faded from memory. The pale blue dot photograph captures Earth from the edge of our solar system. But the perspective it provides is merely the beginning of a journey outward that extends to scales almost beyond comprehension. What Voyager showed us from 6 billion kilometers is just the first step in understanding how small we truly are. Our solar system, with all its planets and moons and asteroids and comets, occupies a tiny region of the Milky Way galaxy. One stellar neighborhood among hundreds of billions of similar neighborhoods, scattered across a disk of stars, roughly 100,000 light-years in diameter. The Sun is one ordinary star among an estimated 200 billion to 400 billion stars in our galaxy alone. From the perspective of the nearest star to our Sun, a red dwarf called Proxima Centauri, located about 4 light-years away, our entire solar system would appear as a point of light, the individual planets far too small and close to the Sun to distinguish. Earth would be completely invisible, lost in the glare of our star. The Voyager spacecraft, despite having traveled for more than 46 years and covering more than 23 billion kilometers, has crossed less than 0.1% of the distance to Proxima Centauri. The interstellar distances that separate stars are so vast that even our fastest spacecraft would require tens of thousands of years to reach the nearest neighboring stellar system. The Milky Way galaxy itself is one galaxy among trillions in the observable universe, a spiral of stars and gas and dust that is utterly unremarkable in cosmic terms. There is nothing special about our galaxy's size, shape, or position. It is simply the galaxy in which we happen to find ourselves. One island of stars in an archipelago that extends beyond imagination. The nearest large galaxy to the Milky Way is Andromeda, located about 2.5 million light-years away. Close enough that it appears as a faint smudge to the naked eye on very dark nights. Beyond Andromeda lie countless other galaxies, extending to the limits of what our telescopes can observe, roughly 46 billion light-years in all directions. This observable universe contains something like 2 trillion galaxies, each containing billions or hundreds of billions of stars, each star potentially hosting planets, each planet a world with its own conditions and its own history. The numbers become meaningless at this scale, too large for human intuition to grasp. And yet all of this, all the galaxies, all the stars, all the planets, all the space between them, emerged from a single point roughly 13.8 billion years ago. An expansion that continues today and that will continue for billions of years into the future. The universe has a history, and we are living in one small moment of it. In this context, the pale blue dot photograph takes on additional significance, showing not just Earth from the edge of the solar system, but hinting at the far greater distances that extend beyond. What seems like a vast gulf, 6 billion kilometers, is actually an extremely local perspective, a view from our own backyard in cosmic terms. The photograph captures Earth from a distance at which our planet is barely visible. Yet that distance is trivial compared to the spaces between stars, which are trivial compared to the spaces between galaxies, which are trivial compared to the spaces between galaxies, which are trivial compared to the scale of the observable universe as a whole. This progression of scales can produce either despair or wonder. depending on how one chooses to respond. The pale blue dot can make us feel insignificant, crushed by the sheer size of a universe that dwarfs us so completely. Or it can make us feel connected, part of something vast and ancient and ongoing. Sagan chose wonder over despair, and his reflection on the pale blue dot emphasized not our smallness, but our preciousness. Not our insignificance, but our responsibility. The cosmic context did not diminish Earth in his view, but rather highlighted how remarkable it is that anything like us exists at all. The universe is mostly empty space, mostly cold, mostly dark, mostly hostile to anything we would recognize as life. Against this backdrop, a pale blue dot with liquid water oceans and a breathable atmosphere and millions of species of living things is extraordinarily rare, perhaps unique in all the cosmos. We do not yet know whether life exists elsewhere in the universe, whether other pale blue dots orbit other stars in other galaxies, whether the phenomenon that produced us has been repeated anywhere else in all of space and time. The question remains open, and its answer would profoundly affect how we understand the pale blue dot. If life is common, if pale blue dots are scattered throughout the cosmos in their billions, then Earth is one example among many. Our responsibility to preserve it remains, but our cosmic loneliness is relieved. If life is rare, if Earth is one of a handful of worlds where biology has emerged in all the vast universe, then our pale blue dot becomes even more precious. A jewel of almost incomprehensible value in a cosmos otherwise barren and lifeless. And if life is unique to Earth, if we are truly alone in all the universe, then the pale blue dot contains not just all of human experience, but all of life's experience, the only place where the universe has become aware of itself. The responsibility to preserve such a thing would be absolute. The cosmic context of the pale blue dot invites us to hold two seemingly contradictory ideas simultaneously: that we are vanishingly small and that we are tremendously significant. The photograph shows our smallness with perfect clarity, a fraction of a pixel in a beam of scattered light. But the photograph was taken by a machine we built and launched, interpreted by minds that evolved on that pale blue dot, understood through science that we developed over centuries of patient inquiry. The same intelligence that can recognize its own smallness is thereby demonstrating its remarkable capabilities. We are the universe contemplating itself, matter that has organized into patterns complex enough to ask questions about their own existence. This is not nothing. This may be extremely rare. The pale blue dot is where this contemplation happens. At least in this corner of the cosmos, the cosmic context neither elevates nor diminishes us absolutely, but places us accurately, showing what we are in relation to what surrounds us. We are small and we are significant, fragile and resilient, temporary and connected to something ancient. The pale blue dot captures all of this in a single image. The universe will continue long after our pale blue dot has been consumed by an expanding sun, long after the Milky Way has merged with Andromeda, long after the stars themselves have burned out and faded. Our moment is brief on cosmic timescales, a flash of awareness in the long darkness. But it is our moment, and the pale blue dot is our world. And what we do with our brief time matters, at least to us, regardless of whether the universe notices or cares. The cosmic context does not answer the question of meaning, but it frames the question in ways that can change how we think about it. The pale blue dot photograph reveals something about Earth that is easy to forget when we stand on its surface. Surrounded by the apparent solidity of rocks and oceans and sky, our world is fragile, a thin film of habitability wrapped around a ball of rock, suspended in an immense void that would kill us instantly if we were exposed to it unprotected. The atmosphere that sustains us is remarkably thin, extending only about 100 kilometers above the surface before fading into the vacuum of space. If Earth were the size of a basketball, the atmosphere would be thinner than a sheet of paper wrapped around it. This thin layer is all that separates us from the cosmic environment. Within that atmosphere, the layer that contains enough oxygen for us to breathe easily is thinner still, extending only a few kilometers above sea level before the air becomes too thin for unassisted human survival. Mountain climbers on the highest peaks require supplemental oxygen. Aircraft passengers rely on pressurized cabins. The atmosphere protects us from radiation that would otherwise sterilize the surface, absorbing ultraviolet light from the sun and deflecting charged particles from solar flares. Without this protection, the surface of Earth would be as lifeless as the surface of the Moon, bombarded by radiation that destroys organic molecules. The climate that makes our world habitable depends on a delicate balance of factors that could be disrupted by changes in atmospheric composition, orbital parameters, solar output, or volcanic activity. Earth has been much warmer and much colder in its past, and the comfortable conditions we enjoy are neither permanent nor guaranteed. The fossil record shows that mass extinctions have occurred repeatedly in Earth's history, caused by asteroid impacts, volcanic eruptions, climate changes, and other catastrophes that fundamentally altered the conditions of life. Species that seemed permanent disappeared entirely, their dominance ended by events beyond their control. We are not immune to such events. The same cosmic environment that has shaped life on Earth over billions of years continues to operate. Asteroids still cross our orbital path, supervolcanic systems still slumber beneath seemingly stable landscapes, and the climate continues to respond to changes in atmospheric composition. The pale blue dot photograph makes this fragility visible in a way that ground-level experience cannot. From 6 billion kilometers, Earth appears as a speck that could easily be overlooked, a tiny bubble of life in an immense dead void. The photograph shows what could be lost if something went wrong. Human activity has added new dimensions to this fragility. Our industrial civilization, altering atmospheric composition in ways that threaten climate stability. Our consumption of resources degrading ecosystems that took millions of years to develop. Our weapons capable of catastrophic destruction on scales that rival natural disasters. The pale blue dot was photographed during the Cold War, when nuclear arsenals held enough destructive power to render much of Earth's surface uninhabitable. Sagan had spent years warning about the dangers of nuclear war, and his reflection on the photograph implicitly referenced the rivers of blood spilled by those seeking to become momentary masters of a fraction of a dot. Climate change was understood in 1990, though less urgently than today, and Sagan's warnings about the fragility of our world have only become more relevant as the evidence of human impact on climate systems has accumulated. The pale blue dot is changing in ways that may make it less hospitable. The photograph cannot show these threats directly. It captures only a point of light without visible detail, but it provides a perspective from which the stakes of such threats become clear. If this is all we have, if there is no backup planet, then risking it is risking everything. The fragility revealed by the pale blue dot is not cause for despair, but for care, not for fatalism, but for responsibility. We cannot control cosmic threats like asteroid impacts, but we have significant influence over the human-caused threats that currently pose the greatest risks to our civilization and our planet. The choices we make collectively about energy, about resources, about conflict, about the atmosphere will shape the future of the pale blue dot for centuries or millennia to come. The photograph reminds us that these choices matter, that their consequences cannot be escaped by moving somewhere else. There is nowhere else to go. The other planets in our solar system are hostile to human life without massive technological intervention. The planets around other stars are so distant that travel there remains science fiction. Earth is our home, and for the foreseeable future, our only home. This recognition need not be limiting, but can be clarifying, focusing attention on what matters most and what we can actually influence. The cosmic perspective does not eliminate human agency, that channels it, suggesting priorities that make sense given our situation. The fragility of Earth is matched by its resilience. The way life has persisted through mass extinctions and climate changes and cosmic impacts over billions of years. Life adapts, evolves, finds new ways to survive when old ways no longer work. The pale blue dot has been through worse than anything humans have yet caused. But the question is not whether life will survive. Some form of life probably will, but whether the particular conditions that support human civilization will persist. The complex societies we have built depend on climate stability, agricultural productivity, and functioning ecosystems that cannot be taken for granted. The pale blue dot photograph, in its stark simplicity, asks us to consider what we are doing to our only home, and whether we are acting with appropriate care given what is at stake. The question has no single answer, but the photograph ensures that it cannot be easily dismissed. Our world is fragile and precious and irreplaceable. A pale blue dot suspended in a sunbeam, containing everything we have ever known or loved. The photograph makes this truth visible in a way that words alone cannot, providing a perspective that changes how we see ourselves and our responsibilities. The pale blue dot photograph has become one of the most significant images in human history. Not because of what it shows, which is, after all, just a point of light, but because of what it represents and how it has been interpreted. The image has taken on a life of its own in the decades since Voyager captured it. The photograph has appeared in countless documentaries about Earth, space, environmental issues, and humanity's future, serving as a visual shorthand for cosmic perspective and earthly responsibility. Directors reach for the pale blue dot when they want to evoke the overview effect, the cognitive shift that comes from seeing our planet as a whole. Environmental organizations have adopted the image as a symbol, using it in campaigns about climate change, biodiversity, and resource conservation. The photograph makes abstract threats concrete by showing what is at stake, not just particular ecosystems or species, but the entire planetary system that sustains all life. Space agencies reference the pale blue dot in their communications about the value of space exploration, using it to illustrate what we can learn about ourselves by looking back from distant vantage points. The image justifies the investment in space science by showing what such investment can reveal. The photograph has been reproduced on posters, t-shirts, book covers, and countless other media, becoming an icon recognizable to people who may not know its history, or even that it was captured by a specific spacecraft on a specific date. The image has escaped its original context to become a cultural symbol. Artists have been inspired by the pale blue dot, creating works that interpret, extend, or respond to what the photograph represents. Music, poetry, painting, and digital art have all engaged with the image, translating its meaning into other forms of expression. Writers reference the pale blue dot in contexts ranging from environmental essays to science fiction novels, using it as a touchstone for discussions about perspective, scale, and human significance. The image has become a common reference point, a shared element of cultural vocabulary. The anniversary of the photograph's capture is marked by articles and social media posts reflecting on its significance, an annual reminder of the perspective it provides. February 14th has become, for some, a day to think about Earth, as well as about romantic love. The pale blue dot has influenced how subsequent space images are framed and interpreted, establishing a template for finding meaning in photographs of Earth from space. Later images, like the blue marble from Apollo 17 or Earthrise from Apollo 8, are often discussed in relation to the pale blue dot. Each of these images offers something slightly different. The blue marble shows Earth in full detail. Earthrise shows Earth from lunar orbit. The pale blue dot shows Earth from the edge of the solar system. But together, they constitute a visual vocabulary for thinking about our planet as a whole. The pale blue dot is perhaps the most extreme of these images, showing Earth at its smallest, most vulnerable, most apparently insignificant. This extremity gives the image its power, pushing the cosmic perspective as far as it can go within our solar system. NASA has embraced the pale blue dot as part of its heritage, featuring the image in exhibitions and publications about the Voyager mission and about the value of space exploration. The photograph has become one of the agency's most recognizable products. Educational institutions use the pale blue dot in curricula about astronomy, environmental science, and philosophy, finding in the image a teaching tool that crosses disciplinary boundaries. The photograph raises questions that cannot be answered by any single field of study. Students encountering the image for the first time often report a shift in perspective, a moment of recognition that changes how they think about Earth and humanity. The photograph has the power to produce the overview effect without requiring anyone to leave the planet. The image has been referenced in speeches by world leaders, in religious sermons about humanity's place in creation, in philosophical discussions about meaning and value. The pale blue dot has proven remarkably versatile, amenable to interpretation from multiple perspectives. The legacy of the image continues to grow as new audiences discover it, as new contexts for its use emerge. as new interpretations are offered. The photograph has become a permanent part of human cultural heritage, a shared reference point that transcends boundaries. The pale blue dot succeeded where many space images have not, becoming not just a photograph but a symbol, not just data, but meaning. The combination of the image itself, Sagan's reflection on it, and the circumstances of its capture created something greater than any element alone could have produced. The image's legacy is not merely commemorative, but active, continuing to influence how people think about Earth, about space, about their responsibilities to each other and to their planet. The photograph does work in the world, shaping attitudes and inspiring action. This legacy will likely continue as long as humans remain curious about their place in the cosmos. As long as the questions the photograph raises continue to matter to those who encounter it. The pale blue dot has proven its durability across decades and will likely prove it across centuries. Future generations may capture similar images from even more distant vantage points, from spacecraft orbiting other planets, from probes venturing into interstellar space, from telescopes that have not yet been built. Each will add to the perspective the pale blue dot provides. But the original image will retain its significance as the photograph that established the visual vocabulary for seeing Earth from the cosmic perspective. The pale blue dot was where we first saw ourselves this way, and that priority gives it permanent historical importance. The spacecraft that captured the pale blue dot continues its journey outward. Now, more than 46 years after its launch, and more than 34 years after it turned its camera back toward Earth for that final photograph. Voyager 1 has become the most distant, human-made object in existence. As of now, Voyager 1 is approximately 24 billion kilometers from Earth, a distance so vast that radio signals traveling at the speed of light require more than 22 hours to cross the gap between spacecraft and planet. Commands sent from Earth today will not reach Voyager until tomorrow. The spacecraft crossed into interstellar space in August of 2012, passing through the heliopause where the solar wind gives way to the interstellar medium. Voyager 1 became the first human-made object to leave the protective bubble of our sun's influence and enter the space between stars. The cameras that captured the pale blue dot were shut down shortly after that photograph was taken, no longer needed and consuming power that could be better used for other instruments. Voyager 1 continues to return scientific data about the interstellar environment, but it no longer takes pictures. The power source that keeps Voyager 1 functioning is slowly declining. The plutonium in its radioisotope thermoelectric generators decaying and producing less electricity with each passing year. By the mid-2030s, there will likely not be enough power to operate any scientific instruments, and communication with the spacecraft will end. But Voyager 1 will continue traveling outward long after it falls silent, coasting on its trajectory through the Milky Way galaxy for millions of years to come. The spacecraft will outlast human civilization, outlast the sun, outlast perhaps the galaxy itself, drifting through the cosmic dark as a permanent artifact of the species that built it. Attached to Voyager 1 is the Golden Record, a phonograph record carrying sounds and images of Earth, greetings in 55 languages, music from around the world, and encoded instructions for playback. Carl Sagan chaired the committee that selected the contents, choosing what to include in this message to unknown recipients. The Golden Record was designed to be understandable to any intelligent beings who might someday find the spacecraft, a time capsule representing humanity at a particular moment in its history. The record includes images of Earth and its life forms, sounds of nature and human activity, and music ranging from Beethoven to Chuck Berry. The odds that any intelligent beings will ever encounter Voyager 1 are extremely small, given the vastness of interstellar space and the rarity of anything at all in the void between stars. The spacecraft is aimed at no particular destination and will not pass close to another star for roughly 40,000 years. Even then, the approach will be distant, a passage through the outer reaches of another stellar system, rather than an arrival at a planet where someone might find the drifting probe. The Golden Record may never be played, its message never received by any ears other than the ones that created it. But the record exists regardless, a statement of intent, a gesture of hope, an artifact that says something about the species that created it, even if no one else ever knows. Sagan understood that the message's value did not depend on its reception, that creating it was itself meaningful. The pale blue dot photograph and the Golden Record are complementary artifacts. The photograph looking back at where we came from, the record looking forward to who might someday find us. Together, they represent humanity's attempt to see itself in cosmic context and to leave some trace of its existence. Voyager 1 carries the memory of having looked back at Earth, of having captured that pale blue dot suspended in a sunbeam. The image data was transmitted to Earth and no longer exists on the spacecraft, but the act of capture is part of Voyager's history, part of what it represents. The spacecraft that showed us ourselves from 6 billion kilometers away now travels through the space between stars, carrying greetings we may never deliver to recipients who may never exist. The mission has transformed from exploration to something more like a message in a bottle cast into the cosmic ocean. The journey will continue for longer than human minds can easily grasp. Millions of years of silent travel through the dark between stars. The spacecraft slowly degrading but never quite disappearing. A permanent addition to the material content of the galaxy. Long after the pale blue dot photograph has faded from human memory, assuming humans exist long enough to forget anything, the spacecraft that captured it will still be out there, still carrying its golden record, still traveling outward into the unknown. Tonight, as you rest, Voyager 1 continues its journey, adding a few more kilometers to the billions already traveled, moving imperceptibly farther from the pale blue dot it photographed decades ago. The spacecraft does not rest, does not pause. The distance between Voyager and Earth grows by roughly 17 kilometers every second, an expansion of the gap that has continued without interruption since the spacecraft launched in September of 1970. By the time you wake tomorrow, the distance will have grown by more than 1 million kilometers. Yet the connection remains, the faint radio signals still crossing the void between spacecraft and planet. The scientific data still arriving at receiving stations on Earth. The conversation between Voyager and its creators still ongoing for a few more years before silence falls. The pale blue dot still orbits its ordinary star, still hosts its billions of humans and its millions of other species, still spins through the cosmic dark that Voyager now traverses. The photograph that connected the spacecraft to its home remains, preserved in archives and reproduced in countless forms, a permanent record of the perspective Voyager provided. The night continues wherever you are, and the thoughts of Voyager and the pale blue dot can settle now, becoming not information to retain, but atmosphere to inhabit. The spacecraft travels on, the photograph persists, and you may rest while both continue their existence independent of your attention. The cosmic perspective that the pale blue dot provides does not demand action tonight, does not require response, does not insist on anything at all. It simply exists, available to anyone who chooses to contemplate it, offering whatever meaning each person finds in that tiny point of light. Earth continues its orbit around the Sun, completing another small arc of the path it has followed for 4.5 billion years. The motion is imperceptible from the surface, but real nonetheless, our pale blue dot tracing its course through space, as it has since long before any human existed to notice. The stars outside your window, if you can see them, include the direction in which Voyager 1 now travels, though the spacecraft itself is far too distant and far too small to be visible. Somewhere in that direction, the most distant human artifact continues its endless journey. The pale blue dot remains what it was when Voyager captured it, a tiny point of light containing everyone you have ever known or heard of, every human triumph and every human failure, every moment of love and every moment of grief. The photograph shows what we are, seen from sufficient distance. And Voyager travels on, carrying the memory of that photograph and the golden record's hope for the future, drifting through interstellar space toward an encounter that may never come. The spacecraft and its message will outlast us all, a permanent trace of the species that looked up and wondered, and eventually looked back. The perspective the pale blue dot provides is available whenever you choose to consider it, a reminder of scale and significance, and the strange beauty of existing at all on this small world. The photograph asks nothing of you tonight, except perhaps a moment of recognition. Rest now, knowing that the pale blue dot continues its orbit, that Voyager continues its journey, that the cosmic perspective will still be available tomorrow and for as long as humans remain capable of wonder. The universe is vast, and we are small, and somehow this is comforting. Good night from the Drowsy Astronaut. Sleep well, and we'll explore the cosmos together again soon.